Llama, Mistral, step aside, because something just dropped that's rewriting the rules of AI on your phone and it's not running in the cloud. Meet Hyena Edge, the model that literally laughs in the face of latency. Built by Liquid AI, fresh out of MIT, this beast is crushing benchmarks and running faster, leaner, and smarter, right on real devices like the Galaxy S24 Ultra. No server farms, no subscriptions, no lag, just raw on-device power that beats some of the biggest names in the game. And today we're breaking down how Hyena Edge is ending the Transformer era and why this changes everything. Let's dive in. For years, the AI world has been obsessed with one thing: Transformers. Ever since they burst onto the scene in 2017 with Vaswani's groundbreaking "Attention is all you need" paper, they've powered everything from ChatGPT to Meta's Llama and Mistral. And yes, the results have been impressive, but there's one massive problem. Transformers don't play nice with your phone. They're memory hogs. They drain your battery. They rely on cloud-based GPUs to deliver their magic, which means lag, latency, and data privacy concerns. Even so-called edge-optimized models like SMLLM2 or Meta's compact 3.21 billion LLAMA variants still rely heavily on those same transformer attention mechanisms, and they're just not built for the limited resources of a mobile chip like a Snapdragon. Try squeezing one of these into your Galaxy or iPhone, and you'll feel it choke. Slow response times, overheating, and apps that crash before your prompt is even halfway typed. And here's the catch: the Transformer's quadratic attention scaling is the culprit. As your input gets longer, memory usage and compute time spike out of control. That might be fine for a server-grade NVIDIA GPU, but your phone isn't built for that. So while we've been cheering on these mega models in the cloud, edge devices, where we actually use AI daily, have been left behind. That is, until now. Just days before ICLR 2025 kicked off in Singapore, a small Boston-based startup called Liquid AI spun out of MIT. Usual Transformer suspects, this one doesn't just run in the cloud, it runs natively on real hardware. Your hardware. We're talking smartphones, not server farms. And it's not just a demo. Liquid AI ran real benchmarks on a real phone, the Samsung Galaxy S24 Ultra. And the results? They weren't just good, they were game-changing. Let's break it down. Hyena Edge is built on a convolution-based hybrid architecture. That's right, convolutions, which traditionally dominated computer vision models, are now being used for language processing. Sounds strange? Maybe, but it works spectacularly well. Here's how. Instead of relying on bulky and memory-intensive attention mechanisms like those found in Transformers, Hyena Edge replaces about 2/3 of the attention blocks in a typical high-end model with something smarter: gated convolutions from the Hyena subfamily. These gated convolutions are fast, lean, and scale linearly with input length. Unlike traditional attention, which scales quadratically. That one change alone brings a huge boost in speed and dramatic reductions in memory usage, especially on edge devices. And Liquid AI didn't stop at theory. They matched Hyena Edge against a top-shelf grouped query attention transformer model with the same number of parameters, a fair fight, and ran them both directly on the Galaxy S24 Ultra. This wasn't a lab test on some NVIDIA A100. Able to start responding was up to 30% faster than the transformer baseline, especially on longer inputs. Decode speed, critical for generating text quickly, also improved significantly once you pass the 256 token mark. Memory usage was lower at every input length. That's huge, especially when your app has to share space with TikTok, Spotify, and your camera roll. But performance is only half the story. The real question is, does it match transformer-level accuracy? Short answer, yes. And then some. Liquid AI trained both models on the same 100 billion tokens and tested them using a battery of standard benchmarks. The Hyena Edge model beat or matched the Transformer baseline across the board. Wikitext: perplexity dropped from 17.3 to 16.2. Lambda improved from 10.8 to 9.4 PIQA. Hellaswag, ARC all saw similar jumps in accuracy. In most cases, Hyena Edge wasn't just faster, it was more capable. And here's the kicker: it accomplished all of this without any cloud, without draining your phone battery, and without losing accuracy. It's what AI was always supposed to be: responsive, local, and private. So while models like Llama and Mistral still dominate the leaderboard in massive cloud deployments, Hyena Edge is winning the battle where it really matters: in your pocket. And with edge computing becoming the next frontier of AI, where privacy, speed, and power efficiency are non-negotiable, that's a win that could reshape the future. Now that we've seen what Hyena Edge can do, crush latency, save memory, and even outperform Transformers on key benchmarks, let's peel back the curtain and look at how this breakthrough actually happened. Because this isn't just a faster model, it's a glimpse into the future of AI design itself. At the heart of Hyena Edge's architecture lies a radical idea: let AI design better AI. Back in December 2024, Liquid AI introduced something quietly revolutionary, a system called STAR, short for Synthesis of Tailored Architectures. Imagine a genetic algorithm crossed with systems engineering. You don't manually design a model architecture line by line. You let an intelligent search framework evolve it. Here's how it works. They start with a pool of primitive operators, things like self-attention blocks, grouped query attention, feed-forward layers, and their Hyena family of gated convolutions, including variants like Hyena Full, Hyena X, and Hyena Y. Then they define constraints, such as minimizing latency, cutting memory usage, and maintaining high predictive performance, all optimized for a real-world device, the Samsung Galaxy S24 Ultra. With that setup, STAR begins its architectural evolution. Over 24 generations, it tested 16 model candidates per generation, each with a unique mix of operations, widths, filter lengths, and configurations. It used real operator benchmarks measured directly on the phone to estimate total latency and memory load, not approximations based on desktop GPUs. That's a critical shift. Most architecture search systems still test performance on high-end GPUs. Each mini-model in this evolution was trained for 5 billion tokens, enough to meaningfully evaluate perplexity, a measure of how well the model predicts the next word, across generations. And as the STAR engine kept evolving the architecture, something interesting happened. One variant began to dominate, Hyena Y. Why Hyena Y? Because it struck the perfect balance. It offered enough expressiveness to model long-range dependencies. It avoided the inner convolution overhead that made other variants slower. It used a lighter gating mechanism, which allowed faster computation while maintaining accuracy. Over time, as STAR evolved these candidates, they could literally see the shift happening. Watch Liquid AI's walkthrough video and you'll see it visually. Bars representing self-attention shrink. Hyena Y blocks grow. Latency curves dip. Perplexity scores improve. It was like watching natural selection, but with code instead of genes. By the final generation, STAR had found the sweet spot, an architecture 32 layers deep with a width of 48, attention head size 64, and crucially 2/3 of the attention operations replaced by gated convolutions from the Hyena family. This wasn't just a clever trick, it was a total rethink of how we build language models, especially for edge devices, but they didn't stop there. They stress-tested the final design again on the S24 Ultra, validating every performance gain at full scale, and it held up. Latency stayed low, memory usage stayed efficient, and the model's performance on benchmarks didn't degrade. But one of the most impressive parts? Hyena Edge's responsiveness on short prompts. That's where hybrids usually fall apart. Most apps, like voice assistants, mobile search, or note-taking, don't use long documents. They rely on queries under 20 tokens. In that ultra-short context, every millisecond matters. And guess what? Hyena Edge crushed its transformer counterpart even there. The prefill latency, the time it takes the model to start responding, was noticeably lower even on short inputs. That's the difference between a seamless model. It's a signal that we're entering a new era of AI, a post-transformer world, or at the very least a poly-architecture future. Transformers won't disappear overnight. They're still incredibly powerful, especially on large GPUs in the cloud. But when it comes to on-device AI, where energy, memory, and responsiveness matter, we're starting to see alternatives rise, and Hyena Edge is leading the charge. Think about what this unlocks. AI that runs locally on your phone, no cloud latency, full functionality without leaking your data to servers, use cases that were once impossible due to power limits, now suddenly viable. Open source access, meaning developers around the world can adapt, fork, optimize, and build on top of Hyena Edge. You might see it running offline on your iPhone, embedded in apps, maybe even powering a Raspberry Pi project. And the beauty of it all, it wasn't handcrafted by a team of elite engineers tuning weights and biases manually. It was evolved, guided by performance data, and optimized for where we actually use AI, in our hands. This is what makes Hyena Edge more than just another model. It's the blueprint for what comes next, and it's already here. So there you have it. Hyena Edge isn't just another model, it's a turning point. It crushes Llama and Mistral in real-world performance, runs natively on your phone, uses less memory, responds more than an engineering win. It's a glimpse into a post-transformer future where AI is fast, private, energy efficient, and right at your fingertips. With open source plans already in motion, this isn't staying locked behind closed doors. Developers, researchers, and creators will have the tools to build, adapt, and innovate without needing a server farm or a Silicon Valley budget. The next AI revolution might not be in the cloud at all. It might be in your pocket. If this blew your mind, make sure to hit like, subscribe, and drop a comment. Would you trust an AI that runs right on your phone? Or is this just the beginning? Catch you in the next one, where the future is faster, smarter, and finally, offline.